are properties of logarithms. We're going to have 3 of them, and they're all going to mirror the same properties of exponents that we had before. Product rule. We just went over that one. When I have a product as an argument, that's when I can split up 2 different logs over a sum. That's when I would add my exponents, so I'm going to add my logarithms. This is the one that mirrored the x to the power of 5 times x to the power of 7. Well, I also have my quotient rule. When I had quotient of powers, remember that if I had x to the 7th over x to the 4th, what did I do with my exponents? Subtracted them. Well, that's what I'm going to do now with my logs. Is I'm going to say log base b of n minus log base b of n. And again, these mirror. When I add exponents is when I add logarithms. When I subtract exponents is when I subtract logarithms. These mirror those same properties we did the very first day of class. Well, the power rule, and this is the rule that you'll use a lot in physics or chemistry, even your business classes, we'll see a lot of examples of these. Power rule says, what if I have a power? What I get to do here is throw it in front as a coefficient. This mirrors if I add x to the 5th to the 7th power. That's when I would multiply powers. What I'm doing is multiplying by the power, by the logarithm. P times log base b of n. I throw that p in front as a coefficient. These are problems that, especially when I have a variables and exponent, I can just throw it in front for free. And here's what's going to happen. Let's look at some examples here. If I have the example of log base a of 9 to the negative 5, which property is this? Well, I've got a power. This is my power rule. What can I do? Throw that exponent in front as a coefficient. This is the same as negative 5 log base a of 9. That would be my answer. And again, a lot of these properties are just getting used to which operation do I use. What if I had log base 7 of x to the 1/3 power? We'll spend a whole unit talking about when we have fraction exponents. Those are radicals, but even if it's a fraction exponent, whatever that exponent is, I get to throw it in front as a coefficient. 1/3 times log base 7 of x. Well, let's look at our other properties. What if I had log base z of 6 divided by u? I have a quotient now. When I had a quotient, that was when I subtract exponents. Exponents are logarithms. This one I'm going to subtract my logs. Log base b of 6, the numerator, minus log base b of u, the denominator. Same way it was always top minus bottom with the exponents. It's always top minus bottom with my logarithms. Now again, when we do these problems, make sure it's that attention to detail that means everything. Now, our last problem, the same way we can split up over subtraction, if I'm subtracting logarithms, this again all hinges off if it's the same base. And these properties will have an almost identical proof to the one we did just a minute ago in the last video, but this only worked because it was the same base. And if it is the same base, what I can do is condense them as a single logarithm, keeping the same base as a quotient. 17 over 27. Whatever comes first is my numerator. Whatever comes second is my denominator. Now, what I would also need to do is, I wouldn't care if it's an improper fraction, but I would need to reduce. If there were a common factor between 17 and 27, I would want to reduce that. Good for us here. 17 is prime. I'm done.